Okay, guys, today we are solving Swiss Mathematical Olympiad 2025 second round. It's for about 200 like smart Swiss guys who will later work in Swiss banks. And the task is G2, it is geometry, and it looks like there are many circles and many triangles that kind of remind us of Swiss mountains. That's what Swiss people like, this sort of task. And circles remind us of lakes. Okay, so let's have a look. So let ABC be a triangle with AC greater than BC. Yeah, that's what we see on the screen. It's in circle, which is inside, touches sides, blah, 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 blah. A DEF, respectively. So you see it's on the screen, not much comment required. Let P be the point on segment AC such as BP parallel to DE. Okay, they are parallel, and let omega be the circumcircle around a triangle AFD. Yes, circumcircle. It sounds long, and so it should be a big circle. Line EF, this line, intersects omega again at Q here, and line PQ intersect omega again at R. Prove that PEBR is a cyclical quadrilateral. PBR sounds to me a bit like BNP Paribas, which is close to Switzerland. I think some impact goes from this. Okay, so what do we do? First of all, as honest mathematicians, we cheat. So we realize that we try to make this circle PEBR, and what happens when we do more or less appropriate picture? Point D seems to be lying on this circumference. We haven't proved it as yet, and this is what we will dedicate the proof. We haven't even proven that 4 points lie on this circle, let alone 5. It's a complete cheat. It's not really a cheat. It is a cheat, but this is what mathematicians call an educated guess. So smart way to say cheat. So how do we prove the cheat? We start with some random angle PBC and call it alpha. So this is alpha. So this is alpha, and alpha for the red circle falls onto PE. Also, we have that PBDE is a trapezium with equal side lengths of PE equals BD. And therefore, we will probably prove it later, if I'm not lazy. Therefore, angle P is also alpha. So angle alpha is here because of the trapezium, and because of the trapezium, points PEDB lie on the circle. Because trapezium with equal sides has basically is cyclic, so there can be circle around it. We haven't proven it really for the point R. Now let us have a look. We have this angle EDC. This angle basically lies on the arc ED of a small circle as inscribed angle, and so does angle DEC. We don't really need even a theorem of inscribed angle. We can just say this angle equals to this angle. And so, what else can we say? We can say that since this angle is alpha, it falls on with the red arc on BE. And this angle, it falls with the black circle on DQ as inscribed angle. And so what else? And so does it, wait, it also falls on PD. of the red, which is more important. It falls on PD, and this angle PBD also falls on PD. So that's why this, if this angle are equal, then R also belongs to the point. And now, because this arc and this arc, they have the same angle, so all the alpha angles are equal, and this finishes everything. So we have proven that PEDB is lie on the same circle because it's a trapezium, and this alpha equals to this alpha, therefore this angle R equals to this angle B, and so RP EDB lie on the same circle, and this finishes the proof. So this alpha equals this angle, so everything lies on the same circle. So we have proven these beautiful tasks, maybe with not such a beautiful picture, but we have nevertheless proven it. This finishes the proofs. Guys, if you have any questions, just don't hesitate to write them for me in the comments. I will read it. And good luck with your Olympiad. Thanks.